Alright everybody, welcome back to Unit 2 Precalc review. And we're just going to do like a little worksheet that has all the test review. So for the first 6 problems, write explicit formulas and complete the questions to find each term. So we want to find term number 10, right? And remember, for an arithmetic formula, your formula will be a of n, that's the nth term, so in this case it's the 10th term, equals a of 1, your first term, plus d times n minus 1. And sometimes you see plus or minus d, but that's only if your d is in absolute value notation. And to find your d, you can do your first term plus d equals your second term. So in this case, your d will be 11. Alright, so to write this formula, let's first start with a general formula. So if a of n equals first term plus 9, which is our d, times n minus 1. So a of 10 will equal 15 plus, I'm sorry, not 9, it's 11, plus 11 times 10 minus 1, which is just a of 10 equals 15 plus 11 times 9, which is a of 10 equals 114. Alright, we're going to skip around a bit so we don't spend too much time on this. So, next up is a question like this. They'll give you your first term, your d, and then the n you want to find. This one is actually probably the easiest format they'll give to you, because all you have to do is a of n equals 95 plus, or I guess it wouldn't be plus here because it's your minus, so it'd be minus 7 times n minus 1. So that'd be n of 14 equals 95 minus 7 times 14 minus 1, which is a of 14 equals, that's 13 times 7 is 91, so it's 95 minus 91. A of 14 equals 4. And you see that since our d here, that's a negative. So if your n is a positive, then it should be less than your a of 1, because you're going down in terms. Okay, and now geometric sequences. So geometric sequences, your explicit formula will be g of n equals g of 1 times your common ratio to the n minus 1 power. And you can find your r by doing g of 1 times r equals g of 2. Alright? So in this case, let's just write a general formula. So g of n equals 72 times, but since these aren't right next to each other, we can't just use that formula. So there's another thing we can do where we take, we can write out two different, well, we don't have to write out two different formulas. We can just do 243, which is a of 4, equals 72, which is your a of 1, times r to the third, because 4 minus 1 is 3. So then you would do 243 over 72 to the cubed root, right? Equals r. And if you do all of that, you should get 1.5. So r equals 1.5. And once you get your r, it's a lot easier from there, because it's just a of n equals 72 times your 1.5 to the n minus 1. Alright? And also, this n minus 1 won't always be n minus 1. It will just be n minus whichever term you use here. So I could write this differently by saying 243 times 1.5 to the n minus 4, because that's the fourth term, right? But, so either one would be fine if you wrote it on like a test or a quiz, right? But personally, using just the first term for everything that you can is just simpler. Keep it that way. Okay, so for this one, we want to find the nth term. Your first term is 2, and your r is 2 times r equals 6, r equals 3, right? So you would do g of n. Also, it doesn't have to be g of n, it can also be d of n, right? Just anything of n. Just whatever variable you want to use. So your g of 1 is 2 times r is 3 to the n minus 1. So that's your formula right there. Alright, next we have some word problems, right? So, okay. Suppose you drop a tennis ball from a height of 18 feet. Once after the ball hits the ground, it rebounds to 85% of its previous height. How high will the ball rebound after its third bounce? Okay, so a thing that a lot of people get tricked up on is whether this 18 is your g of 0 or if that's your g of 1, right? And there's not really like one thing I can say that will fit every time, but it's kind of like a case-by-case basis. So here you're dropping it from a height of, say this is like a graph that shows the height. You drop it from a height of 18, right? And then it bounces, 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 bounces. So in this case, your 18 feet would be your g of 1, because that's your starting value. That's where you drop the ball from. That's not after the first bounce. That's before the first bounce. So you want to make a geometric sequence here because it says 85%. And if it's a percentage like that, you're going to want to do a geometric sequence. Okay, so g of n equals 18 times 0.85. Okay, it's important to use 0.85 because if you use 85, that means your ball is going all the way up there. You don't want that. You want your ball to bounce, bounce, bounce. Okay? You don't want your ball to... It wouldn't make sense for the ball to be higher than when you first threw it. And so since your 18 is your g of 0 term, you would do n minus 0, which simplified is just n, right? So once your third bounce, so g of n equals 18 times 0.85 to the 3. And that should equal, roughly, says round to the nearest tenth. That would equal, in tenths, that would be 11.1, okay? Alright, question number 9. It says, use interval notation to state the domain f of x equals ln of 3x squared minus 19x plus 20. Okay, so we know that with a logarithmic graph, you have a vertical asymptote, and then your graph looks somewhat like that. Or it could be, transformed to look a different way. But what you have to know is that there will always be a vertical asymptote, because it's the opposite of an exponential, which always has a horizontal asymptote. So anyways, to find the vertical asymptote, or the domain of a graph, you need to find where 3x squared minus 19x plus 20 is bigger than 0, right? Because that's your, that's just where it's bigger than 0, because your original asymptote will be on the line x equals 0. So it has to be bigger than that. It has to be to the right. And so what you want to do here is, well, just solve it like a factor, right? So you will have, let's see, 3 times 20 is, we'll use big X method. So 3 times 20 is 60. Drop the negative 19 and put 3's under. All right, so what times what equals 60 and adds up to negative 19? So that'd be negative 15 and negative 4, right? So that'd be negative 15 over 3 cancels to negative 5. Sorry. X minus 5 times negative 4, 3 doesn't cancel, so we do 3x minus 4, right? There we go. So you would have your domain. Gosh, doesn't want to cancel out. Goodness gracious. All right, so your domain will be from x is bigger than 5 and x is bigger than 4/3. So since they like look at a number line, say that's 5, say that's 4/3, well, they overlap here. So in this area, sorry, they overlap in this area over here, which means just overall your graph will be, have a domain of, x has to be larger than 5. And in interval notation, that will just be 5 to infinity. All right, converting logs to exponential form. So you remember, well, hopefully you remember that this is your base, this is your exponent, this is your answer. Pretty simple, right? Okay, number 11, write an exponential model, g of x equals a to the bx, that fits the points 0, 12, and 1, 8. So you see that it's a gap of 1, and it decreases from 12 to 8, right? So we would just do g of x equals, well, your first term is 12 right there, times b, which is same thing as your r, right? Your rate that it's decreasing, and 12 times x equals 8, x equals 2/3, so 2/3 x. There you go. That's in a function form. Okay, or would it? No, it would have to be, hold on, I'm sorry. Would that work? Yeah, that should work. Wait. To the x, to the x, to the x. Yeah, that would work, because where x equals 0, you plug in 0, that gives you 1. 12 times 1 equals 12. So that's a little way you can fact check it, if you're not sure like me. Alright, number 13. We've got a word problem here. So it says the number of units sold is given by the function n equals 1700 ln 9t plus 7, where t is the number of years after the product was introduced to the market. And what are the expected sales 8 years after the product is introduced? So it's just saying 1700 ln 9 to the times 8 plus 7. Okay, so your t here in this situation is the number of years after the product was introduced to the market, and that's just 8 years after. So 9 times 7 is 72, 79 ln 1700, right? And well, this is your exact answer, right? But if you plugged it into, say, like Desmos or your graphing calculator, you would get a different answer, right? You'd get a super long decimal. I'm just stalling right now so I can type it in. 1700 ln of 79, which will be roughly equal to about 7,428 models, or products, sorry. Because you can't really sell half a product. Well, it depends on the product, but you usually can't sell half. Alright, so the amount of time in years required for a certain radioactive material to decompose is T equals ln R minus ln A over K, where R is the mass of the substance remaining after the decomposition, and A is the original mass of the substance, and K is a constant related to the particular material. Find the time required for 50 grams of the radioactive element to decompose so that only 18 grams remain if K equals negative 0.427. So it says your A is your original mass, K is the constant, and R is the substance remaining, right? So ln, so we'll just kind of plug in things, right? So it wants me to find the time, which is t. So I don't have to move anything around because the t's are by itself. So ln of remaining would be 18 minus ln of original is a, so ln of 50 over minus 0.427. So I'm assuming they would give you a calculator on this, but if they didn't and they just wanted you to write the exact answer, you could further simplify this by doing ln of 18 over 50 over minus 0.427. Because if you know your log rules, log base c of b minus log base c of a will equal log base c of b over a. And this property only works if your bases are the same, right? Logarithmic properties. You guys know that. Alright, so we're going to skip this question because it's just using regression models. And all you really need to know is that you just plug it into your Desmos or your graphing calculator, gives you your model, blah, 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 blah. And the best model is the model where if you look at the residual plot, there is no clear pattern at all. So it's just kind of like spread out like that, right? Now, examples of a pattern would be something like this, something like this, something like this. So really, you don't want to see like any kind of graph inside your residual model. You just want to look really random. Okay, so use the graphs of f and g to evaluate the following functions. So f of g, so this is f of g of 0. So g of 0 here is 3, right? And now you take that value and plug it in here, which is 1. This is just really straightforward. And f of g of 2 is just another way of writing f of g of 2, right? So 2 of g is negative 3. Negative 3. Yeah, and negative 3 here is 4. So this would just equal 4, right? Fairly simple. In this one, you know, f of 2 is 3, and g of negative 4 is negative 2. Plug that into f. It would be 2, so just 3 over 2. Fairly simple. And this one is just g of negative 2 of f times, so f of g of 2, blah, blah, blah. Yeah, I mean, you guys know how to solve this stuff, right? It's really simple stuff. You don't really have to show your work, I guess, except for kind of drawing it out. Alright, So this one wants you to draw the function and the inverse. So I'm going to draw these really roughly because I just can't, I just can't, draw a perfect graph freehanding it. But, let's start with this one. So, negative half x. So you can just plug in values here, like, 0 is always a good one to start with. So if you plug in 0, that would actually give you, 5. 0 and give you 5. X equals 0 gives you 5. X equals 1. So, or let's do 2. So, 2 squared times minus 1/2. 2 squared is 4 times minus 1/2 is minus 2 equals, I'm sorry, not equals. Minus 2 plus 5, 3. So 2 is 3. And then since it's a quadratic function, we can assume that this is there. Actually, don't assume that's there. You should also plug in -2 to check that. But I know it is -2. And really, you should check more than like 3 points. You should have like maybe like 5. So that would be like, I don't know, maybe something there. I don't know. But I'm just trying to get this done for the video. So I'm just going to say it's something like this. Alright? It's your basic upside down quadratic graph. So any type of graph you have, I would recommend you use the points. X equals 0, x equals 1, x equals -1. And if it's a log graph, it's easier to plug in your y's. So I would do y equals 0, y equals -1, y equals 1, right? Just like your basic 3 points. So I know I just said that 3 points isn't enough, but they say it's enough, but honestly, I don't think it's enough. And you should listen to me. And also, oh yeah, inverses. I'll show you with this one. Find the inverse of a graph. You want to set it equal to y. And just switch your y and x around. And then solve for your y. So here would be, you isolate your variable first. So that'd be x minus 3 equals 2 to the y. And then let's take logs of both sides. So log base 2 of x minus 3 equals log base 2 of 2 to the y, which simplifies with your logarithmic rules into y. So this would be your, actually this would not be your inverse function. You don't want to make it equal to y. You want to make it equal to f of minus 1 of x. They'll be particular about that. So this is your inverse function, okay? Okay, they want you to solve for x in these functions, right? So, with these, it's really important to know your log rules, and I'm not going to go over them all, because you should already know these, but if you do need to know these, just search up, like, log properties, or, like, manipulating log rules, and there should be some, like, cheat sheets, and, like, little sheets that have all your rules on them for you. But definitely know those for any type of quiz or test you have. Okay, so log base 3 of x plus log base 3 of x minus 8. All right, so same base, right? And it's a plus, so you can multiply them. Log, anything like inside these parentheses, you can multiply. So x squared minus 8x equals 2. So let's do log to the 10 on both sides to get rid of this log here. Because, to the 3. Yeah, to the 3 on each side to get rid of that log. So, we'll do 3 to the 2 equals x squared minus 8x. 9 equals x squared minus 8x. I'm gonna delete this up here. Hopefully you guys already got all this down. Alright, so x squared minus 8x minus 9. Okay, this is basic factoring. If you don't know this stuff, you shouldn't be in Precalc anyways, alright? So get your factoring down. So that'd be x minus, God, Do I know this? X minus 8, x minus 9, x plus 1. Sorry. So that would be x equals 9, x equals minus 1. All right. But, you have to check for extraneous roots. Set everything here bigger than 0. X must be greater than 8. Also do it with this side, but that's just going to give you x must be bigger than 0, which is included in x must be greater than 8. So that means you have to rule that out, because that's less than 8. So x equals 9. Bang. Which one looks hard here? Let's do this one. This one using a square root, and everyone freaks out whenever they see square roots, everyone freaks out. But don't be scared, because square roots are actually some of the easiest ones to do. So once you just solve for x, well, let's get that logarithm out of there. So it'd be e to the 1 equals root x plus 2. If you just change it to exponential form, which you should know how to do. So if you want to get rid of square root, you square it, right? So whatever you do to one side, you have to the other. E squared equals x plus 2. X equals e squared minus 2. Easy as that. And since e is one of your irrational number, is that an irrational number? Yeah, because pi is irrational. So e is an irrational number, 2.871 or 781 or something like that. I don't really care. But since it's an irrational number, just leave it as it is, because you can't simplify it anymore. Okay, next questions are word problems. Everyone hates word problems, but they're a big part of the test, so you have to know them. And the FRQs are kind of a pain in the ass, too. Okay, suppose the half-life of a certain radioactive substance is 60 days, and there are 12 grams present initially. Find the time when there will be 2 grams of substance remaining. So half-life, remember, is just your half-life over x. No, I'm sorry. It'll be x over your half-life. Okay, I'm sorry. I don't know what I'm doing. A of n equals your initial amount times your since it's half-life, it's 1/2 or 0.5 to the x over 60. And if you forget that, remember that you want this number to get bigger as your time increases. So 5 over 60 is obviously going to be greater than, like, 1 over 60, right? But 60 over 5 is actually less than 60 over 1. So if you forget that, you can do, like, little things like that, little nuances like that to figure it out. But I would recommend just remembering this. So it'd be x over 60. And, well, this is obviously a calculator one because no one wants to do anything to the 60th power. So 12 times 0.5 to the x over 60. Since they want you to find the time, and that's your x. Sometimes you also see t over 60. It doesn't have to be 60. That's just because that's your half-life, right? And it wants us to find the time where there will be 2 grams remaining. So set it equal to 2. I'm going to delete all this up here, so I have room to work, but you guys know what's supposed to be up there, or you can just scroll back in the video. But let's just solve it like it is. So 2 over 12, let's move the 12 over, 2 over 12, that's 1/6 equals 0.5 x over 60, right? Get rid of that now. Well, so we can just do log base 0.5 1/6 equals I think I messed up somewhere. I definitely messed up somewhere. Okay, this isn't looking well. I'm sorry, I'll redo it really quick. 2 equals 12. Nope, I did not mess up. Crap. Okay, I'm sorry about that. Log of 0.5 to the 1/6 equals x over 60. So x equals 60 times log 0.5, 1 over 6. And if my numbers are like kind of wrong, just know like the basic thing you need to do here is right. Okay, so like don't say, oh, you did your numbers wrong, you got the wrong answer. Well, like I'm just teaching you how to actually solve the problem, so just don't complain about it. So, and if you do that, you'll get roughly like x equals 155 point I don't know, 0.9775. And since it's pre-calc, round to 3 if you have to round. So 0.098. Okay? And don't forget your unit. It's days. Alright, last page at last. Let's get this done. Find the logarithmic regression equation. Okay. This will just plug into put this into Desmos. Find your log equation. Log base A or B of A plus blah 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 blah. Put that in, okay? And then once you get that in, you can just do x equals 12, and I'll draw like a straight line going up and down at 12, and where your log equation crosses that, the y value there will be the f equal f12, okay? You guys know how to do that, you should. And what's the residual for the data value for 5.2? Now, if you go to Desmos, there'll be a little button that says plot residuals, right? And if you go to the residual that's at 4, your y value there will be your residual. So don't worry about that second half, okay? The only thing you worry about is find the value where x equals 4 on your residual plot. Okay. Semi-log equations. Okay. You actually don't have to worry about semi-log, so I'm not going to go over that. But let's look at the other one. Okay, this one's logarithmic regression too, so don't worry about this one either. Just put in or actually I do worry about it, but you know how to do it. Put in the Desmos, put in the table, blah, 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 x, y, and here your x will obviously be days, because your x variable is always your independent variable. Okay, find the natural log of y and plot the data, x, ln of y on the grid provided. Okay, this is also Desmos, just regression, so you guys can figure the rest out.